Hello everyone, welcome to this tutorial. In this tutorial, I will be explaining how to use PVsyst software, which is widely used in the solar energy field. So to do this task, we just need to type PVsyst on Google. So here is the website PVsyst.com, and from here you can download the PVsyst by clicking this button. So there are different kind of licenses, free licenses and paid licenses. Of course, paid license offers additional or more sophisticated functions, but the free version also works fine. So in this case, I downloaded the free version. So from here, you can also see that the latest version, PVsyst 6.74, is released on this date, which is just 10 days ago. So you need to click this button to download this, but to save time, I already downloaded this PVsyst installer. Here is my installer. So I think it was required 5 minutes to download the file. So I already downloaded the installer. So after double clicking this installer, this window shows up, and you just need to click next, and you need to agree with the terms. Of course, you need to read all these conditions and terms of use. But in this tutorial, because of time, I just clicked accept. I just ticked here and click next. And in this directory, the PVsyst will be installed, and next. And finally install. So it will take 5 seconds to install PVsyst. And so now I'd like to talk about similar tools. Finished. Similar tools. So there are similar tools like PVsyst, for example, PVsol and Homer. So in this tutorial, I just choose PVsyst to explain, but to your specific needs, you can really choose what kind of software do you use. You can choose PVsyst or PVsol or Homer or any others online tools you can choose. So here's the PVsyst application shows up. You just need to double click to open PVsyst. So here's how PVsyst looks like. So there are different tabs: preliminary design, project design, and databases and tools. So in this case, I will start with the preliminary design because it's a beginner level tutorial. So let me start with the basic level. So here's the preliminary design, and there are 3 different systems. So the first one is grid connected, which is connected to the grid. So the electricity produced from the PV panel will be supplied to the electricity grid, and from electricity it will be distributed to the final consumers. And the standalone system it's the system it doesn't connect it to the grid. So the PV panel produces electricity, and that electricity doesn't go to the grid. That electricity is directly consumed by the local consumer. And pumping system, which is used for hot water pumping. So let me start with the first grid connected system. So grid connected system is like this. PV panel produce electricity, direct current DC, and DC is converted to the AC, alternating current, by this inverter, and this AC alternating current will go to the grid. So this electric meter will measure how much electricity that I supply to the grid, and also in case of nighttime or in case of cloudy days, how much electricity that I use it from grid will be measured by this electric meter. So it has 2 directions. One is going from PV to grid, and one is going from grid to the PV. So this is the overall scheme of our system. So we can choose the specific site where to install the PV panel. So we can name our project. So let's just name it as my project. And we can choose the country and site. We can choose wherever in the world. from here. So now I live in Japan, so I can choose Japan as shown here. And also I showed Fukushima, where I live. So if you open this site, you can retrieve the information. And also you can input the geographical input by mechanically, for example, latitude, longitude, and its altitude, etc. And also you can see the sun path. So from here we can see the sun path. So as we already know that winter, December 22nd is the shortest day in the northern latitude, shortest day. So as shown here, line number 7 is December 22nd, which is the shortest day, and also the sun height is really low. On the other hand, during summer, like June 22nd, the longest day, the length of the day is the longest, highest, and also sun height reaches its highest. As shown here, June 22nd, illustrated by line number 1. So this is the sun path we can see from here at Fukushima. Okay, that's all. We can close this window and we can click OK. We already choose our location to install PV system. And here's the horizon tab. As we already described it here, here's the sun path, and you can adjust this bar to choose the horizon. But my recommendation is better to be here. Why? Because we can use all the available solar energy and turn it into electricity. So my recommendation is to be like this. And okay. And we can choose the system. So we can choose either one of these 3 options. For example, one is the active area. How much area available do you have? And the other one is the nominal power. How many power do you want? And the other one is annual yield. How much energy do you want in a year? So you can choose either of these. So in this case, I'll choose nominal power. I'll choose a system which is nominal power is 50 kilowatts. And the tilt of the PV panel will be 30 degrees, same as the latitude. So in that case, we can retrieve the most of the available solar energy. For example, in equator, where is the latitude is 0 degree, equator, we can the PV panel should be 0 degrees. It doesn't have to be tilted. It just should be placed on the horizontal surface. So we can click next. And we can choose what kind of model are we looking. So there are standard and other models, and also we can choose technology: monocrystalline, polycrystalline, and thin film. All of these 3 kind of technologies are available in the PV market. So in this case, we'll just use polycrystalline as default. And also we can choose where to place. For example, flat roof, or facade, or tilt roof, or ground based. Let's just leave it as a default. And also freestanding, ventilated, or no ventilation. So we can proceed by clicking OK. And we can click results to see this report. So we installed PV at this location, Fukushima, and the nominal power is 50 kilowatts hour. So the module costs this. For each watt, I choose 50, so for each watt it costs 111 Japanese yen, and the technology is polycrystalline. So to this 50 kilowatt power, we need this area 332 per square meter, and the annual yield will be, it will generate 60 megawatt hour of electricity in a year. So all the investment will be this amount, 20 million Japanese yen. And the energy costs this in Japan. For per kilowatt hour, it costs 32 Japanese yen. So from this graph, you can see that we can see the available solar energy. The red bar is indicating available solar energy at horizontal surface, and the green one is indicating on a tilted. So from here, if we tilt the PV panel, as I already said, at 30 degrees, we can receive more solar energy. And here's the how much electricity will be produced from the system, as indicated this. So during during April it will produce maximum energy, and December it will produce minimum energy because the day of the length is short on December. So average is it produces 160 kilowatt hour in a day. And if you look at this, it will shows these numbers are shown in a table by month. And here's economic growth evolution. So here's for the model itself, we need to invest this amount of money, 5.5 million yen, and also support cost and inverter and wiring and transportation. So the total investment will be 20 million yen. And also here's the maintenance and annuities. So for every year we need to spend additional 1 million yen. And I already said this electricity price. So we choose here Japanese yen because we installed in Fukushima. And the system duration is 20 years. It lasts 20 years. So after 20 years, we need to replace all the PV panels and other equipments and etc. And here's the preliminary result. But if you wanna do, do you want to save it? Yes. So we can save our project. My project, name it here. We can save. File name is Fukushima, and just click save. And later we can retrieve this our project and click exit. So it's done. And if you want a more detailed analysis, more detailed simulation, instead of using preliminary design, you can choose project design and grid connected. Then you can simulate more detailed simulation. And also you can always choose standalone system for your own specific, for your family needs, etc. So hope that you enjoyed this tutorial, and also thank you so much for your attention. Hope that this tutorial helped you. Goodbye.